Hello and welcome everyone to the top 10 Onshape features of 2024 live stream. One of my personal favorite presentations for the year. Couldn't be more excited to dive into this with you. So without further ado, let's get started. I want to start obviously with our introductions. My name is Cody Armstrong, the Senior Director of Technical Services for the Onshape team here at PTC. And I'm very fortunate as always to be joined by our Head of Product, Greg Brown.
Thanks, Cody. It's great to be back again. I can't believe it's been a year since we had this same meeting talking about 2023's top 10. But yeah.
Yep, it's one of my favorites. I know we've talked about it before, and I'm really excited to be here. I think that a lot of our users are going to be really excited. If you haven't paid close attention to the improvements of the year, I think you're going to be really stoked to see some of these things. And for those that have, I think it's going to be a great reintroduction for some of these awesome new features. So let's dive into it. Now, before I get into the specifics, I'd like to take a step back and look at the year as a whole. And I always like to show this slide. This is from our product team because it's daunting. It's a wall of text, but it really does reinforce all of the improvements that we've done throughout the year. For those not familiar, Onshape releases every 3 weeks and roughly 17 improvements. We're actually very close on our last improvement or last update of the year. So if we had been, just a little bit later, this list might have looked a little different. But it's an exciting thing because there are hundreds of improvements we could have picked from this list and even more to highlight for you here today. So we really had to cherry pick the best improvements throughout the year and show them to you here today. But also just to reinforce the frequency and the cadence and just the constant update cycle that happens within Onshape.
Yeah, I want to say this particular slide is really just the cherry-picked list. I mean, we counted up more than 700 actual improvements that we did through the year, through these 16 so far releases. And what also is not evident quickly, because it's a very daunting list, as Cody said, that it covers a really wide gamut of the whole of the product. It's not in any one particular area. Whether it's PDM, whether it's modeling, whether it's drawings, whether it's advanced applications, there's something here for everybody.
Yeah, agreed. And a great segue into our topics for today's presentation. Now, as Greg mentioned, we could cover any number of different things, so we have to narrow these down to just the window of time that we have to present to you. And so what we've done is picked a handful of categories to nominate improvements from. And that's what we're going to do here today, is go through some of these various categories and some of the bigger improvements in each category. And at the end of today's presentation, really highlight what we feel are the top 10 improvements for 2024. But as Greg mentioned, this list could get long. The list of categories, it's broad. In 2024, we added improvements in nearly every facet of the product. And you're going to see that in a lot of today's presentation. But in short, drawings and PDM are always important functions of Onshape in that list. Core CAD, something that I'm going to focus on here in just a moment. I'm sure many of you will be interested in seeing. Surfacing, Greg has some really awesome examples of some of our surfacing improvements throughout the year. Sheet metal, I know a lot of users will really appreciate those sheet metal users out there creating sheet metal parts. And then user experience, something that affects everyone and something that is universal across Onshape. And then finally, rendering. Rendering got a ton of improvements this year, and we're going to go through and highlight some of those for you. But those are the various categories that we're going to focus on today. We're going to pick these categories and go through and nominate a handful of really big improvements throughout the year in each one of them. So to start things off, I'm going to start with the core CAD nominees. And I think this is something that everyone out there will appreciate because it's the list of the core functionality of Onshape and some of the bigger improvements to exist in that core CAD functionality. And I'm going to go through a handful of these and just highlight them, but I want to do a demonstration of a few of them as well, just to really emphasize some of the bigger improvements and how you can get started using them. So I'm going to start with lock subassembly. I think that's something a lot of people appreciate, especially those doing big top-level assemblies. Locking the subassembly has big performance implications, and in just general usability makes subassemblies much easier to interact with at the top level. Pause regeneration, another kind of performance-oriented improvement that allows you to pause the regeneration of your Part Studios and then resume it at some other point. Again, with the notion of saving time, right? Increasing that or decreasing that regen time. Decals. This is actually something we did very early on in the year. I believe it was in January that we added decals, and I think that's something that many users requested since day one of Onshape, and we now have it. And we have the ability to insert those decals in the Part Studio, see them in the assembly, see them in shaded views in the drawing. Something I think a lot of people will really adopt and use quite often. The Sketch Profile Inspector, another small but big improvement in terms of day-to-day usability because of your ability to define and find those sketch profiles that may not be relating in the way that you expect. So it's a great troubleshooting tool for that. Also, Repair View, another great troubleshooting tool. This one really uses our unique architecture to lay out how you can repair geometry and how geometry came to be in the place that it's in. And really awesome tool for visualizing how you can fix any kind of problems that you have in your model. So these are the beginning of the core CAD nominations that I really wanted to focus on. And I wanted to spend a little bit of time first on locking the subassembly. And there are a few applications for this, but I think a lot of them really relate around performance. So I would encourage those out there that are doing the more complex assemblies, the bigger assemblies, with lots of mates to solve. This is going to be especially useful to you. But even those that are building, relatively, let's say medium or smaller size assemblies, but want to capture those subassembly named positions, right? And so let's go into how to use this. In this case, this is an awesome looking engine. And if I dig into it just a bit, let's do a section view of it, fully detailed all the way through. And what I'd like to point out is you'll notice a handful of lock symbols in the instance list of the assembly. That is the new lock position functionality in Onshape. And what you'll see here is that these subassemblies are all locked. But what's really neat about this is that it's more than just the ability to lock the subassembly. You also have the ability to follow a position. And this is something I like to stress to people is you can actually capture the position of a named view at the subassembly level and use that in the top level. As you can see in this situation, I have a carburetor for this engine. It has two named positions at the subassembly level for this carburetor. Of course, we have the idle position, right, which has the valve closed. You give it a moment, there you see the valve closes, and I have the wide open throttle position. These are named positions created at the subassembly level that I'm capturing it for use in the top level assembly. And so it's easy for me, and what we find in most users is they really just want to be able to reflect the important positions of a subassembly in the top level. They don't necessarily need free motion, right, or the ability to grab and drag. It's just, I want to capture certain positions in that top level. This allows you to accomplish that. It allows you to quickly be able to say, move this into the named position that I created in the subassembly. Now, I mentioned before the performance implications of this, and I think this is really a big reason to take a look at locking position and the ability to use those named positions from the subassembly is that it considerably cuts down on the mate solve time. And just to demonstrate this, in this case, this is an assembly with 52 mates, 291 parts. And the thing I always like to stress is a 16 millisecond mate solve time, which is incredibly fast. And I think that this is one of those tools, especially as you get into more and more parts, more and more instances, more and more mates, the benefit of lock position will only grow, right? And it'll be one of those tools that you use for every top level assembly to make it faster to navigate.
It's probably worth pointing out also too that this just doesn't affect the subassembly itself, because you could open the subassembly and it's got all the motion in the world that you wanted in there, right? And it's fit for its purpose. But the purpose here at the top level is to have a kind of static, except for one or two areas that you might want to keep in motion. So it gives you the full control over that.
Yeah, and it allows you to capture those popular positions and the ones that really matter to you. But again, to stress, if you're in that world of building big assemblies, this is a tool that can have a dramatic impact on your mate solve time and really improve the overall performance of your assembly. So one that I really encourage you to take a close look at as you start to build those big assemblies. All right, so that is lock position, and more importantly, the ability to follow that named position, something I think a lot of users will really appreciate. So what I'd like to do now is dive into my next example, and this is actually one that we've had for some time now. This came early in the year, in January of 2024, and that is the ability to add decals. And this is something that's been requested from day one, probably one of the most requested improvements that we have in our list today. And I think that, for good reason. People like to be able to add company logos or images associated with like warning labels or things like that to their models, see them in the assembly, see them in a shaded view of the drawing, and have that, that kind of behavior that they would expect from decals. So how do we do this? Well, the first step, and an important step, I'm going to roll back just one moment here, is make sure that you've imported the image into your document first. So it's much like sketch image and other capabilities around you. It must be a tab in the document before you can insert it. But from that point, it's a pretty straightforward feature. You select decal, you choose your image from the document in this case, or it could be from other documents if maybe you have a library of warning labels or whatever it may be. And then you define a face to place the decal on. So I just click this face. What's really neat about this is we'll automatically define the boundaries of the face and apply the decal to that condition. So it's essentially sizing the decal based on the geometry that you select. But you can manipulate it. So there's angle, of course, there's UV shift, and you can realign. So if I don't like the size, I can even just grab the manipulator and change that on the fly. And I can move it around, rotate it, do any of the things that you'd like to do with that decal. But that's really all that there is to applying the decal. It's very simple to do. It's just a matter of selecting the face and positioning it in the place that you'd like. The thing I like to stress about this, though, is it does automatically apply to both the assembly and shaded drawing views. So there's nothing that you have to do to show the decals in the assembly or the shaded drawing views. They're there by default. So that is decals, a simple one to show, but I think one that people really appreciated. And actually, it's been almost a year now. It's been, I believe, mid-January is when we added this. So this was early in the year.
Yeah, there's a sort of bonus tip on decals as well, is that they're so easy to use and so powerful and so kind of visually impressive that I like to use them just for notes to myself too in the actual model. This side up kind of thing, or this is port versus starboard, or just reminders to yourself, not even intending them to ship that way, but just while I'm in the model building process, you can put things as visual reminders for yourself.
Yeah, great application for it. Not one that I had thought of, but something that I think a lot of users will appreciate. I've seen people take notes and add text and things like that to accomplish something similar. So great advice. All right, so that is decals. The next thing I'd like to jump into are a handful of additional core CAD nominees in my list. And the first that I'd like to focus on is the ability to exclude from the configuration. We'll refresh here in just a moment. Exclude from properties. So bear with me just a second here. I'll jump into the slide. And so in this set of nominations, there's really two that I wanted to make sure to highlight. And that is the ability to exclude from properties and the body draft feature. And I think both of these were really well received by our users, something that a lot of users really appreciated for two different reasons. I'll go over an example of each in just a moment. But exclude from properties, body draft, really notable improvements in the year, some of the most requested, and I think some that our users will really appreciate. So let's start with exclude from properties. And the reason I want to start there is I think that it's a very common workflow to work with parts that are moving. For whatever reason. So I'll give you an example of a coilover where you have a spring that compresses. And you can think of like wire routes that move, or any number of parts that have different states that they may be in, depending on the compression and rebound, or the position of wires in a moving subassembly. There's lots of examples where things move and you want to capture that movement, but they're not necessarily different parts or configurations. And let me explain what I mean. I'm going to open up the bill of materials, right? Well, let's start up. Let's jump to the assembly and start there. You'll notice that I have this spring in my subassembly, and the spring doesn't yet have a part number. And that's because I actually have two configurations of the spring, and they represent the rebound and the compression state of this coilover. And in the rebound state, it does have a part number. But in the compression state, it does not. And that's because in Onshape, by design, configurations have part numbers have configuration specific numbers associated with them, fields associated with them. And that means that when you create a different configuration, like a compressed spring, it has a different part number by default. And that's by design. I think for majority of situations, that's the behavior you'd like. If you're creating traditional configurations, you'd want each configuration to have its own unique part number. But in the situation of like a spring compressing, right, or an O-ring and showing a expanded and regular state, you really want the same part number in both of those. And so in that situation, it makes more sense to do what we've added in this release, exclude those configurations from the properties. And the way that you do that is in the Part Studio. We'll open up the Part Studio here, go to the configuration panel, and you'll see the two configurations that exist for the spring. And you'll see an additional option in the ellipsis menu in the top right, exclude from properties. What that will do is it will use the default configuration, the properties, the part number in this case, from the default configuration for all configurations of that, in this case, spring. And so when I go back to my bike shock, right, you'll see the compression configuration now has the same part number as the rebound configuration. It's not changing. So they're all the same, right? And so no matter what compression state I represent in this spring, it will have the same part number. So think of all of that geometry that has, a compressed state and a rebound state or a normal state, lots of different applications where things move and may be positioned differently depending on the configuration. That's an excellent example where exclude from properties will really make the biggest difference. So just a tip for those out there, anyone working with these kinds of parts that may move or change shape, an easy tool for making sure that your part numbers match the various configurations. So moving on, my next topic that I'd like to talk about is body draft. And you can think of a body draft tool as, I want to be able to draft the entire body in a single feature. We have our draft tool. You can think of this as like draft on steroids. It's one level up in terms of its complexity and the capabilities and so on. And an excellent example of this is, something that is a nonlinear draft where you're drafting about a surface that you've defined, and it's especially useful for symmetric drafts where you want to take an entire body and draft it in two directions simultaneously. That's really where it can be quite useful. So to demonstrate this, let's go ahead and open up our body draft. And you can see we have a number of different options here. We can define a draft scope, faces, parts, edges. I want to do parts in this example and draft the entire part. And then I want to say faces to exclude. So we'll wrap things around, grab those faces to exclude, and select them. Then we define a pull direction, very similar to the regular draft feature. We define our pull, and then define our parting entity. Now, in this situation, it's not linear. It's a surface that I've defined that actually represents kind of the mid-surface profile for this particular brush. And so I can select that, and you can see instantly that I get the draft on that particular body. Now, where this really comes into play, where I think this is tremendously useful, is the symmetric draft, because you can check an option to make that draft symmetric. And so if you have a situation where maybe you've defined everything as a single body, but you're ready to start splitting it into its multiple pieces and doing the necessary draft, great. You can do that in a single feature using body draft, right? Define body draft. And now you can see I have in this case, 3-degree draft going in both directions, right? Another big benefit of this is you have the ability to really define carefully how your parting faces meet, right? And so you can define different match types for the faces where the parting line exists, and define, either tangent to the face or define it by a reference edge. So really an in-depth draft feature that allows you to draft not only a combination of faces, but entire parts in multiple directions in a single feature. It's something that I think a lot of users have asked for, especially in the world of like injection molded or molded parts in general. where draft and defining that parting line very carefully is particularly important.
So Cody's already, throwing up some pretty interesting nominees here. It's going to be a pretty tough choice to narrow this down at the end. But this one particularly is such a powerful feature. I mean, it wraps up so many things that Cody did, and there's even more to it. Incredibly complicated things in the past can now be done in this single feature, all in one. So yeah, it's probably it's an early leader in my book. This one for the overall challenge.
Yeah, and it's one that I think a lot of people out there, anyone doing draft and has used our traditional draft tools, they're great. But if you're getting to the higher end of that spectrum of doing molded parts, it's going to be a game changer for you, I think. And I think that a lot of users out there were really excited about that feature when we added it. So that is body draft. Now the next one isn't necessarily a category, but a feature all its own, and that is, drum roll, thickness analysis. And this is one that in my book is one of the most requested features, one of the ones that I hear about most from our users. Where's thickness analysis? When are we going to get thickness analysis? And I'm excited to announce it's there. We have it. It was added just recently, and it's one that I would say not only did we add thickness analysis, but we did it in a way that's very Onshape, right? And I'm going to show you what I mean by that in just a moment. But for those out there, again, similar theme to the last model, if you're doing molded parts, this is something I think you're really going to appreciate, really going to love using. All right, so let's dive into an example of it. And for this example, I have just a common injection molded part. So in this situation, I have, in this case, this is the rear handle for our jackhammer assembly, and it has some injection molded parts. You'll see here, I'm going to do thickness analysis on this part. Now, our list of analysis tools is growing, it seems like, with every release. So we have a long list of analysis tools. Greg has covered some of these in past presentations. I know we've covered them in other places. But you'll see a new one, thickness analysis. I choose thickness analysis from my analysis tools, and then I select the part that I want to analyze. Now, it's important to stress in this situation how complicated from a computation standpoint thickness analysis really is. This is one of those things where we're taking advantage of our unique architecture to scale this very quickly. Notice how quickly I got results back from that thickness analysis. And it's very similar to simulation in the sense that we can scale to an infinite degree in our compute resources, and we can render in a progressive way. So we can give you results instantly, where in many systems, this is a lot like simulation and other tools where you kind of hit go and walk away and come back a few minutes later. Onshape's thickness analysis is really fast, especially considering the computation that it's doing. So again, go ahead, Greg.
I was going to say, I mean, hitting go and walking away might be actually productive compared to what a lot of people do, which is hit go and stare at the screen, waiting for their computer to come back to life again, because these are computationally expensive things. So the Onshape way is to use the Onshape compute resources, which are in the cloud, obviously, and you can switch tabs and do other things that you were doing before, and come back to the thickness analysis, in 10, 15 seconds when those first results come back through. So it's an exciting, the way that we've done it is really, I think, really we're proud of, right?
Yeah. Yeah. And very similar to simulation and how it even look and feel. And that's a wonderful thing from a consistency perspective, but also just highlighting just one more time how our differentiators, how our architecture is our advantage here. And in this situation, we can take a really complicated injection molded part and run thickness analysis in, maybe 10 seconds to generate this. And so just highlighting again our ability to do these complex, computationally expensive operations quickly and in the cloud. Now, a few things about thickness analysis I would point out. First off, you have really two methods. You have a rolling ball method, which is kind of the industry standard, and a very quick ray method. Ray method is just a simple projection, a simple ray between the two surfaces that defines the thickness. It's a very quick and easy kind of simple first run thickness analysis. It's also more useful in simpler geometry. But when you get into the more complex geometry and you want the more robust thickness analysis, I think rolling ball applies. And you can think of rolling ball as a sphere inscribed inside of the two adjoining surfaces that you're analyzing the thickness of. And so that, of course, gives you a lot more depth to the thickness analysis and is, generally considered the industry standard. Now, you have, of course, color options. You can also define the bounds of the thickness analysis if you choose to. So if you're focused on a certain area, you can certainly do that. Grab the legend, drag left to right, and you can define those bounds. By default, they will be defined by the geometry itself. But that's really it. The last thing I would point out about thickness analysis is I can interact with the model while thickness analysis is on. And one of my favorite things to show here is doing a section view. I'm going to grab a surface. Let's do a section view. And now I'm sectioning the model and it's starting to probe the model, especially in the case of thickness analysis, while in a section view. And that's something I always really like to highlight with our thickness analysis. I can continue measuring. I can do sections of the geometry. I can interact with it while it's in thickness analysis. So one of my favorite features of our new thickness analysis tool. All right. So that is thickness analysis. My next topic is drawings. And I really want to jump into drawings head first. And there's a lot of things we could highlight. So I'll do my best to highlight what I think are the most important. But there's a long list. And I wanted to take a moment to acknowledge that, right? So first off, what are my favorites? Well, automatic inspection items, in my opinion, is probably one of the biggest improvements to drawings in this year. And the reason I say that is it's such a unique way that we've done it, and it's so well integrated into our inspection tables, our drawing environment, that I think it's a very unique solution to inspections in Onshape drawings. But we've also added a whole host of improvements around this and drawings in general. So nominal and tolerance columns. You can now add a nominal and tolerance column in the inspection table, combining those two and making it easier to read, something that a lot of users requested from our inspection table. We also have entirely new detail view styles, stacked callouts for balloons, custom table inserting into the drawing, grouping callouts with views. There's a long list of things that kind of made my personal favorite list for 2024. And just to emphasize this more, we've put together a slide of all the improvements to drawings just this year alone. And this isn't actually all of the improvements. These are just the noteworthy, improvements that people get excited about in drawings. There's more to it actually than this. But it just gives you an idea of going back to the volume and scale of improvements. 16 releases so far this year, and each one of them have added a considerable amount of depth to our drawings in Onshape. So just to highlight this again, drawings, if I had to highlight a single area of the product that got the most attention, the most single number of improvements, I think that drawings would be high on that list, just given the sheer volume of new improvements coming to drawings. So let's take a look at automatic inspection items. And the reason I want to start here is I think this is the most important improvement, in my mind at least, for 2024 in the drawing realms, because it's so well integrated into the drawing experience as a whole. So here is the gear cover from that same jackhammer assembly. This is a separate part from that, but it's a drawing of it. And in this situation, what we want to do is identify a handful of dimensions here that are associated with inspection items. And so what you'll notice is the inspection table that flies out from the right-hand side. This is essentially a list of all the dimensions that exist in the drawing. So as you create dimensions, you're going to see they'll be added to the inspection table, but they don't have items yet defined, right? And so these are just a list of all the drawings or all the dimensions and the tolerances for each in this drawing. But I want to go through and add inspection items. So we'll go ahead and collapse that down. You'll see the inspection item icon in the toolbar, and adding inspection items is really quite simple. Attach it to the geometry, or in this case, the dimensions associated with it. And as I add them, you'll see that they're added to the inspection table as well, automatically. So as I mouse over them, you'll see they highlight, so I get the cross-referencing, and I can see that now the top 3 dimensions in this situation are the 3 inspection items that are most important to me or whomever may be doing, the inspecting, the quality assurance work. So important to stress, automatic inspection items, very easy to add. Your dimensions are automatically there just as a function of Onshape drawings. And now it's even easier to come in and begin to add those inspection items as you see fit, right? And could be easier to use and to monitor. And quick tip for those that are using inspection tables, you can export these as CSV. So in the top right menu, in the ellipsis and 3 dots in the top right, you'll see an option to export to CSV, like the name implies. Especially useful if you're taking this data and moving it downstream to, perhaps a QA station, CMM, something along those lines. So inspection tables, something I think a lot of users will really appreciate. Automatic inspection items, the whole inspection kind of workflow is something that I think is very unique to Onshape and very much worth pointing out. If you haven't used it yet, if you're doing inspection tables by hand still, inspection items by hand still, I definitely recommend trying that out. All right, so my next topic, I'm going to move through things quickly here just so we get to our various topics for the day, is PDM. And in particular, a handful of PDM improvements that I think a lot of users will really appreciate. First and foremost is an entirely new way to navigate your data. And this is something I think is very unique to Onshape. I think that a lot of users will really appreciate this when they start to dive in. And that's what we refer to as product structure view. Rather than navigating your data based on a nomenclature of documents or folders, and many traditional systems, files and the folders that they're stored in, you have to know that structure in order to navigate the assembly or the drawings or the parts themselves. In Onshape, we're giving you a new option for navigating your data, and we refer to as product structure view. Rather than being bound by folders, by documents, by those units of measure that we're kind of used to, you can now navigate your document based on its product structure. What parts, assemblies, drawings, what exists within this product, right? And I think it's a much more natural way to interact with your data. Also, in the same topic of PDM, workspace protections, merge lines, selective restore, all very important improvements. And in fact, you'll see that there's a whole series of Git-inspired PDM level improvements that came in 2024 in Onshape. I'm just highlighting a few of them here, but they really make the Git style workflow of branching and merging frequently with different changes possible in Onshape, and add a layer of effectiveness to that Git style workflow in CAD. So I'm going to highlight a handful of those as well. But these are just some of the PDM nominees that I would highlight with 2024, right? There's a long list that we could go into. But for the sake of time, I'm going to jump back one more time to the documents page. And this is not normally where I start a presentation, but in this case, list view, right, and product structure view are on the documents page. And I start with kind of the default view. So here I've navigated to an assembly. It's in a folder for rotary engines. And what I see at this level is just the top level assembly, right? I don't see any of the underlying structure of this product. And in order to do that, I would have to navigate to a number of different folders, right? I may have some things in library component folders. I may have some things in separate projects that are shared. I may have some things in totally different directories. But what's important here is I, as a user, I don't really have to know where all those various pieces are located. I just have to turn on our product structure view. And instead of structuring the data based on the folders that it exists in, now I'm structuring that data based on what's actually in the product, right? And so I can't stress this one enough. If you're navigating today using list views and struggling to find the right folders and directories that all the various components exist in, try turning on structure view and just seeing how you navigate it. Because now I'm navigating my design based on its structure, right? And more importantly, the latest as-built version of this, the latest released version of this. And so it's important to stress you're looking at the latest released version of this product and all of the released parts and subassemblies that exist within. You can see my top levels at Rev C, but I have a handful of releases that are Rev A, Rev B, and so on.
So what I like to say, Cody, is like you come for the CAD, but stay for the PDM with Onshape. Or in other words, this is we're showing you the CAD demo that you expected, but this is the PDM demo you needed. Onshape is really unique in the way that CAD and PDM are the same. There's not two systems that are hacked together and joined together with some kind of other technologies. It is one system, right? And even to talk of them separately, it doesn't really make that much sense. You're looking at Onshape here just as the way that you were looking at Onshape in a core assembly demo or a surfacing demo or anything else. So that's what makes Onshape such an easy system to get started with and really sort of springboard to the next level.
Yeah, absolutely agree. It kind of it eliminates that obfuscation of folders and having to understand navigating structures. It's really just about what is the structure of my data, and to Greg's point, how we're able to do this is unique to our architecture, right? We're not using a traditional structure of files and folders to manage the data. We can access, your product structure because it's unique to our architecture. So something I always like to stress, product structure view, something I think a lot of users will appreciate. I think a lot of users will turn this on and leave it on because it's a simpler way to navigate your products from within Onshape. So that is product structure view. I definitely recommend turning it on. It's one that I think most users will leave on once they turn it on and never go back. So the next one that I want to mention in terms of PDM is there's a whole series of what I would refer to as like Git-inspired PDM level features that I would highlight in 2024. And what they've really done is enable a more broad set of capabilities. And so I just want to take a moment to highlight these briefly. Here I have a handful of branches and inside of this, versions in history. And one of the first things I want to highlight is the ability to lock or enable workspace protection. And I think for most users today, what they're going to do is turn on main and lock down the main branch. And what this does is it prevents changes except for merges. And so you can have an approved branch that gets merged into main, but you can't open main and start modifying, right? Unless you disable the workspace protection. And so for a lot of users out there, it allows you to have that one sacred branch, and you can have as many branches as you want where you modify things and change things up. And once it's approved and it's ready to be merged into main, you can do that, right? And so it gives you an extra degree of control over those protections associated with a branch. One more degree of ability to approve a design before it gets pushed into main. And a very common theme, if you're familiar with Git and style software development, and what we're doing is bringing those workflows to hardware development as well. Now, it's not just workspace protection. It's also simple things like merge lines. When you do a merge now, you will see the line indicating that has been merged back in. We also have additional filter options where you can filter by just the branches with workspaces or the current branch, simplifying what you see here to something that can be manageable, especially as you start to get into many branches. So one of the things that I really like to highlight in 2024 are these Git-inspired improvements, workspace protections, merge protections, even things like selective restore. There's another improvement that came in 2024 that would fit in this category, the ability to selectively restore documents to a certain point in time and not necessarily restore everything in the document. So that is workspace protections, merge lines, selective restore, a whole host of features that I would kind of categorize as Git-inspired PDM features that have improved the experience in 2024. All right. Go ahead, Greg. Anything?
I was going to say, this is a really good example of, the benefits and the power and the differentiation of Onshape's platform, where it can really just spring forward springboard ahead of where traditional systems have been for the last 30, 40 years. The modern world works in ways that are much more agile, much more collaborative. The software world has taught us how this works very, very well, with agile techniques. So it makes 100% sense to use the same kind of approaches for hardware development, because most hardware development does involve software. Maybe not this ArborPress, but most other projects that you work on do involve software and engineering and hardware and ECAD teams all together. So it's time for the MCAD world to come out and adopt these types of processes too. And with Onshape, it's just a natural.
I agree. And the customers we've spoken to who have adopted these processes absolutely love it. It's a different style of workflow, but once you get the hang of it, it is a really awesome way to work. And I think a lot of users really appreciate it, especially those coming from any kind of software development world where these are just common practices. These things are table stakes.
Yep.
All right. So those are the PDM topics that I wanted to mention. The last thing I want to bring up, actually, I have 2 more slides, so bear with me for a moment here. The next is sheet metal. And there are a lot of improvements I could highlight with sheet metal in 2024, but I really cherry picked 2 that I think if you're going to follow up and go into Onshape and start using these things, sheet metal bend and the corner break improvements were really notable in 2024. Sheet metal bend was one of the most requested improvements in sheet metal that we had. And it's one that I think a lot of users will appreciate. If you're not using it today, definitely go try it out, especially for those that may be importing DXF, so flat patterns, or working a lot with imported flat patterns in general. It can be especially useful in that workflow. All right, so I'm going to dive into this one last time and jump into my sheet metal part. Bear with me for a moment here. And I mentioned this before, but it's really critical when you're working in any kind of flat pattern. Now, there's other applications for it, to be clear. I don't want to stress that it's only useful there. But in this example, here I have, a sheet metal part that I've bent that essentially started as an imported DXF. And in this situation, I import a DXF with a flat pattern, and then I need to go through and define this as a 3-dimensional model. And so let's roll up and do that. I'm going to roll up to that point where it's just a sketch. I'm going to create a sheet metal model. I'm going to choose thicken in this situation. We're just going to thicken all the surfaces that make up what in this case will be our flat pattern. So here I've gone through and defined here all the faces that are going to be involved in this flat pattern. I can define any of the other settings that I need, thickness and bin radius and so on. But then I hit OK. So now I have the basic sheet metal part started. Now this is where sheet metal bend is particularly useful. So you'll see in the sheet metal dropdown the option for bend. Now the way it works is very simple. You define a bend line and a face to bend. So in this situation, I can select a line like this one, right? And then define a face to bend. Now in this case, it's actually attached to that face, so it automatically recognizes it. I didn't have to select a face. But notice the bend that happens, right? So there's my first bend. Now, one big tip, this is kind of a tangent and not necessarily related to bend, but very useful in it. You can use the Shift Enter to accept a feature and automatically bring up a new instance of that feature, right? And especially useful, like in this case, where I have a lot of bends that I want to go through and do. Let's see how quickly I can go through and bend this part up. I'll just use Shift Enter to accept and just continue selecting lines until I've bent the shape. I've created the shape that I want, created all the bends that I want. And I'm just using Shift Enter to accept, move on to the next feature, and select the next line. And so it's very quick for me to go through, define all the bends in this part, just using Shift Enter to repeat it, right? And so now I can go from what is a flat pattern, DXF, that I've imported, to a folded model quickly, right? And so one more bend after this one, and I'm good to go. Right. So just a tip, Shift Enter, by the way, applies to lots of features. If you find yourself in a situation where you're applying lots of back-to-back fillets or any other features, Shift Enter is really useful there. But the big tip there, the big improvement to point out is the new bend feature. Now, there's other applications for it. Inserting, DXFs is a common one. But any situation where you want to sketch a line and then bend about that line, That's where this is particularly useful. Something I think a lot of sheet metal companies, a lot of sheet metal users out there will really appreciate. All right, so I have one last slide, one last highlight, and I will pass things over to Greg and move on. So the last thing I wanted to mention just briefly, I don't have anything to show for it, but I do want to highlight it, is the new Onshape Educator Plan. All the teachers out there I know will be clapping for this one. This is something that our classrooms have really asked for years. We've had it in Enterprise, Onshape Education Enterprise. Now we have a dedicated Onshape Educator Plan for those teachers out there. It comes with classes functionality, assignments functionality, and then also Onshape simulation, which is one of the most requested features for our education plan. So I think for a lot of students, a lot of teachers out there, this is probably going to be your favorite improvement for the year in 2024, and we're really excited to bring it to you. All right, so we have just a little bit of time left. I'm going to pass things over to Greg to jump into his presentation.
Okay, thanks, Cody. That's a pretty impressive list. I'm going to be hard pressed to beat that, but I've got a few candidates here, a few nominees here. So let's dig into some pretty specific and niche areas of modeling, and this is going to be the surfacing topic here. A lot of strong nominees this year. And the last couple of years of Onshape have seen a great amount of work and effort and momentum around surfacing and surface modeling. Of course, we don't really differentiate it in the user interface. It's just modeling, right? It's just in, you're building parts, and they can be free-form aesthetic things like some of the stuff on the screen here, or they can be prismatic or sheet metal. It's all in the same environment. We really try and break down the barriers between doing these sorts of things. That being said, there's some specific things that we've added, such as a G2 or curvature continuous boundary surface. This is how surface that you create might need to connect to surrounding surfaces. And the G2 boundary condition is really important for that, for some of these high quality surfaces. We introduced a flattened surface operation, which I'm really excited to demonstrate to you. This was in the previous release of Onshape, so it's very fresh and very, very exciting, and it works really, really well. Speaking of fresh and new and exciting things, we have a edit curve feature, which is kind of unique and novel in the way that it works, and it's incredibly powerful for a great number of workflows, including fixing imported dirty curves or curves that were created using other techniques, which they might not be as clean and as smooth as you want them to be. Really important one. Offsetting curves was added this year as well as even what's more than G2? Well, G3 is more than G2. G3 bridging curve adds another level of boundary condition control to make really, really smooth aesthetic curves. And I will demonstrate a few of those things. And finally, a really long word, isoparametric. Isoparametric curves are used heavily in advanced surfacing techniques, and those are now within reach of all Onshape users. Let me switch over and show you a couple of those right now. So I'm building this surface model here, and I'm in a part studio. And I've actually used a previous winner, I think, here from last year, the face blend, to create a blend between two faces. But what I'm going to try and do is build this corner, right? It's a complicated set of surfaces coming together, and curves are typically used to help guide those things. Now, in order to break this gray surface up right here, I could use a number of different ways to trim it. I could just throw a plane through there and trim using a plane. But what happens when you do that is you end up with a complicated split edge. What is better is to use what we call an isoparametric curve. And an isoparametric curve, in really short, extracts the mathematics of the underlying surface and uses one of those isoparametric lines on the surface there, and therefore it doesn't have to create any approximations. So by doing, throwing this isoparametric curve in here, and it's very, very easy to use. I'm just choosing the direction for it and how many I want, or if I want, equal space, 10 of them along here, or if I want it at a specific point like I do here, then I just create that curve. then I can split and delete that face. And this edge that we've created here now is very, very clean. In fact, it's a nice clean edge for us to start using some bridging curves to connect into, which is the next thing here. So a bridging curve is a workhorse feature that's very, very powerful and very, very easy to use. It's under the curve tool set up here. You'll see that this tool set is actually getting longer and longer every time we log into these sessions, right? So the bridging curve can now do position, tangent, curvature, and also G3, or what we call flow. So what this does, again, very, very simple, short explanation for a complicated and highly technical topic, is that it adds an extra control point, and it raises the degree of the single span Bezier curve that we're creating in here. Probably used a lot of words that you might have to go and look up in Wikipedia or somewhere, but the fact that we can do this now enables users a lot more control over the aesthetics of the geometry. And these things all go together. In fact, I've used the isoparametric curve, the face blend projected isoparametric curve, bridging curve, and now a boundary surface all in conjunction here. And you'll see that with boundary surface, we also have the ability to match curvature as well as tangency. These all work together, as I said, really, really powerful tools in the kit that you need to create free-form aesthetics and highly manufacturable surfaces like this in here. Right. So I could go on with this one for a lot longer, but I'm going to show you a really exciting thing in a different area, which is flattened surface. So I've got this formed shape. It's going to form the nose rib of an aircraft wing. And I want to know the flattened shape of it. Now, you might have seen this as a kind of a preview or a spoiler alert from Cody's demo, but there's another analysis type down here as well, which is the ability to pick a bunch of faces and then just flatten them. All right, so you see, it's a very, very simple thing to do, very, very fast, and it gives me a lot more control than I just showed you there as well. What I might want to do is provide rips along some of these edges. And you'll see here, once I re-flatten it, that those tears, manifest themselves in the flat pattern as well. So once you've got this, what you can do is export this in large number of formats like SVG, DXF, Parasolid, or STL. And you might then want to create drawings, use these in downstream operations for the flat. Couple other flattened demos while we're here. In fact, this is a really, really nice one. The fact that this works with mesh models as well. So this was a GLTF model that I imported. It's a surface. It could have been a solid, but whatever. And I can flatten that as well. So the use case might be here is that you've got a scan of some surfaces that you wish to apply a decal to, or maybe some paint protection film, typically on the front bumpers of cars and things like that. So you can create, again, that and export the flat out to different formats, send it to your laser cutting table or whatever else you're going to use to cut this decal with. And yeah, just to not be outdone by that, there's this one here. So I've created half of a soccer ball or football, depending on where you're from. And what I can do is flatten this. I'm just going to pick all those. Now, if you were trying to wrap this in paper for, say, a birthday present or some kind of other present, you would have a very strange sheet of paper. In fact, one that stretches quite a lot, right? Which is not paper. So if you had a sheet of Lycra or something like that, then you could cut this shape and stretch it over like that. And you would have a nice flattened surface. However, that's not reality for a lot of materials. So because of that, we do show this analysis where distortion is going to be. Now, the red areas are where you're going to get a lot of crinkling and folding, and where the blue areas are where you're going to have stretching. So paper doesn't like to do that. So you might need to provide some additional controls along the lines of the rips that we talked about before. So you can imagine this, and I've actually done this, and I can't show you right now because there's not enough room on the camera, but if you create this shape and then cut it out of paper. You ready for this? If we turn this upside down and have a look at the bottom, watch what also happens to the red areas. All right, so the red areas are now eliminated because we're not distorting as much as we did before. In fact, you can cut this and lay it over a form shape like this and get pretty close. We also have some other controls and visualizations so that you can see where the distortion is likely to occur, and you can see these curved lines coming from the flat lines down the bottom. Pretty exciting stuff. Flatten surface, part of the analysis tools menu down here in Onshape. Moving along to the edit curve. Now, I've touted this one as a possible, it might be a champion. I don't know. It's got champion DNA and blood in it, I think. So often what happens with surfacing is that you bring some curves in, and these are imported curves, and then I created a loft through them. Now, at first glance, the loft looks okay. If you know what you're looking for, though, there's potentially some issues down here. So I'm going to invoke a couple of controls, and I'm going to do that using a zebra look here. So you can see here some significant problems down here in this loft. Now, if you use this to do downstream operations such as splitting or booleans or even thickening, you'll see that some bad things start to happen. So this is definitely a question or a case of you should measure twice and cut once. You should make sure that your surfaces are good before you do some things like thickening them or boolean or other operations downstream. Right, so that one's very obvious, but it's not always so obvious. And what do you do about it? Right, what can you do about it? Well, we have included this new capability called Edit Curve right here in the Tools menu for curves. And you can pick a curve and you can manipulate it in multiple different ways, right? So one of the most important things to do is to reapproximate a curve. And you can see here, when I do the reapproximation, the points along here, which are the control points of that curve, are being reapproximated in different ways. And I can put tolerances in here. I can keep the start and end curve tangencies the same. And you can see here, I've got also the ability to manipulate the position of those curves. So if I have, say, curvature turned on, I can, move these things around until I get a much, much better shaped curve. Now, there's more to it. I can also planarize curves. I can elevate curves. This is a sophisticated tool, but incredibly easy to use. So I'm going to go back down here, and you'll see this is the before shot, and I'm going to unsuppress. And in fact, this is a nominee in the next section, the ability to unsuppress a whole folder of features. Here we go. There's a bunch of these edit curves here. If I unsuppress them, just like magic, it fixes this. And you see how good, and I can compare this, again, do the before and after shot. So the before is very, very ugly, unusable, and after is smooth and great. What is really, really interesting for those following along is that even after editing these curves, I didn't have to update the loft or the thicken feature or any of the things downstream. In fact, basically, I did, I changed the wheels as we were driving along, so to speak, and I changed the definition of the curve, but while it was maintaining the curve identity that was being used by other features downstream. Incredibly powerful, and Edit Curve is a worthy nominee for the 2024 list. Let's go back to slides for a second here. And I've already, and Cody and I have already touched on some of these, but user experience is such, an important day-to-day, quality of life type thing. And we spend a lot of time using the software ourselves and feeling how it would be better to do certain things. And so we do we put a lot of credence in this area. So lots of nominees: dark mode, keyboard shortcuts. And I've actually been using a couple of these keyboard shortcuts, and I'll come back to that and show you. Providing more colors so that it can differentiate intent. Here's a bit of a swerve curveball here. back in February, we introduced an Onshape Vision app. On the day one of the launch of the Apple Vision Pro, we had an app ready. And it provides an incredible way of collaborating and manipulating and experiencing models in a visual spatial way. A lot more things in here with mate connectors. Mate connectors are like the heartland of good modeling. You can use them in so many different ways. So this is just one example of how we've made mate connectors better in 2024. The ability to just pick an instance and automatically put a mate connector at its origin. That's going to be really, really important when you bring things together into an assembly and you want them to line up nicely. Sketches, you spend a lot of time, or you spend as little time as possible in sketching, but when you do spend your time there, you want it to be fulfilling and a good experience. So we've done some work here in providing visibility of the expressions and variables that you're using in there. Also with sketches, are they constrained? Are they under constrained? A quick way to view that is now possible. Weights and measures, measuring mass properties, there's things like that have been improved. Lots of little user experience things to do with that, and I'll show you some of these in a minute. Suppressing whole folders, I did demonstrate that already. And there's one other one here, which is when you have missing references in a list like this, in a selection list, it's very easy now to right-click on it and say clear the missing references, or indeed clear all the references, which you could have done in the past with the spacebar, but now we make it a lot clearer for everybody there. So I'm going to demonstrate a couple of those things right now. So here's my favorite parametric wing model. It's got a bunch of variables that are controlling everything in here. And if I click on a sketch now, I can really quickly see that the f of x symbol here means that there are expressions controlling this dimension. And in fact, if I roll over it, you'll see the expression itself is shown to you. So you can really, really quickly, as you roll over these different things, see which variables and which expression involving the variables was used. These little things add up when you do this multiple hours per day, every week of the year. And, we are very focused on these types of things. Also, with colors, you can see here that I've assigned colors to different sketches. And to me, I have my own nomenclature for, blue, primary blue is for a primary sketch. Red is for projected sketches and things like that. You can come up with your own intent in here. Finally, in Sketch, I've got an area that I'm trying to block out in the middle here. And you can see here the sketch that it's involved with has a nice new symbol, which means that it's not fully defined. It's not a fully constrained sketch. So this may or may not be an issue, but at least you can see here quickly, without having to go into the sketch, that it is indeed an under constrained sketch. So while we're here, I'm going to cut a quick cross section, move it around. And you see, we've got a nice cross section through here. I can go to the mass properties now and show you that we can do face properties. In fact, I'm going to pick all those faces there, and you'll see instantly I've got second moment of area, or the area moment of inertia, displayed for this section. So I didn't even have to have geometry there or a plane there. I actually just did it with a section cut manipulation there. Really, really fast stuff. We want to keep you in the flow of design, so we don't want to put any barriers up to these kinds of things. All right, I'll quickly flip back to one last topic, and it deserves every moment here, which is rendering. So in 2024, we essentially rewrote the Render Studio. So the new Render Studio stands alone as a nominee here. There's lots and lots of parts to it. There's lots of enhancements that it unlocks. And, this image here actually kind of describes a few of them. Because we rewrote it in the way that is totally Onshape, because it is Onshape, it supports versions, the version graph, the branches, merging, all of those types of things, which makes it really, really handy to use when you're looking at multiple people collaborating, or just when you're coming up with crazy ideas that you want to try and then maybe reject or merge back in. We support transforming objects really nicely. We support the 3D connection, 3D mouse, space mouse. We provide a lot more control over the quality of the tessellation. And in this one here, the appearance management, collates a bunch of different things to do with the appearances. And I'll just quickly show you a couple of things here. So it looks much more like Onshape. It provides access to a lot more capabilities in rendering, such as here, I'm changing the lighting image that I'm using, which is actually an external resource coming from linked from a different Onshape document. Okay, you can see here, so you can see the familiar link icon here to this image. So some of these advanced capabilities, and things like depth of field and tone mapping, stylized views, all of these have been in Render Studio for some time. They just become a lot more accessible and obvious to you in the new form of Render Studio. You can see the familiar diamond logo here, which means I've set tessellation to very high for some of these objects that have curves in them that I want to come out at a very high quality. Really, really easy to use. You just right click on it, set the tessellation to whatever level you like, and then you get a chance here to reset the tessellation back later. Interesting note, I mean, I'm using a space mouse here at the moment, and this is a really, really interesting thing for our platform. Again, we're running pure cloud native stuff here. So we have to come up with some really interesting and novel schemes as to how we can maintain performance, even though we're running on perhaps a Chromebook or a Linux laptop or whatever we're running on. So you get the full power of our cloud service whilst running on whatever hardware that you like. So talking of like this rendering enhancement that I mentioned at the beginning is the ability to use versions in history. So I've got I'm in my main branch here, but over here, I'm actually in a different branch, which I'm using as a kind of a test for, I'm changing the different environment, the rendering. I'm just fiddling around with some appearances. And in fact, I've done one more thing, and that is to include a model from a different document here. So you can see the mannequin that I've brought in is actually coming from a different Onshape document. And I can manipulate it just in the same way that, I can isolate it, I can hide, I can show it, I can suppress it, because it is Onshape, right? We're using all of the same techniques here in Onshape. So, I could go on and on about all of these topics and some of these that we probably have forgotten to mention today, but I'm going to hand it back to Cody now to wrap things up.
Sure. Thank you, Greg. My favorite example of all the ones that you've shown was just that first one where you had I think it was four simultaneous examples of surfacing improvements back to back to back. And I think about what that would have looked like last year. It's a pretty dramatic difference. And just looking at the collection of surfacing tools, curve tools that you see in the dropdown, it's a lot of growth in just the last calendar year. So. All right, so we're going to wrap things up here today, and we're going to take a handful of the improvements that we've mentioned, nominated, and pick our top 10. And I'm going to start with number 10 and work our way to number 1. So I'm going to start with number 10, bear with me, Onshape Educator Plan. I think this is one that the students and the teachers are going to appreciate most, but I think in general had very big impact to Onshape in 2024. G2 Boundary Surface is one that Greg showed, and I think that a lot of users have been requesting, and it's now there, something that will be very much appreciated. Decals, what I showed you earlier, that was one of the most requested from a user perspective, and I think people will really appreciate it, coming in at number 8. Number 7, automatic inspection items, something I showed you just a moment ago, something that if you're doing inspection items in the drawing, something that will make that a lot easier. Number 6, new Render Studio. Now, this is a whole category of improvements like Greg mentioned. Render Studio really did get a rework, and it involves lots of things, so it's difficult to put any one improvement because there's just so many that were big. But the entirely new interface and workflow for Render Studio is definitely on the list in the top 10. The Git inspired PDM features, these are the ones I showed you earlier: workspace protections, merge lines, selective restore, all that kind of stuff falls under the category of Git inspired PDM. And I think that a lot of users really appreciated that for 2024. Surface flatten. Greg had an awesome demo of it with the soccer ball. Lots of different examples for this, something that people have been asking for quite some time. Dark mode coming in at number 3. I think this one is something that people turn on and leave on and have been requesting for some time. If you have dark mode on in all your other applications, great. Now you can turn it on in Onshape as well. Product structure view. This is something I showed you a moment ago, an entirely new way to navigate your product. Rather than using folders and your documents, you can navigate using a natural means of navigating the product's structure. And finally, drum roll, number 1, last improvement that I want to mention here today, thickness analysis. I think that thickness analysis of all the improvements that we talked about here was most requested, has the biggest impact for the users out there, and something that I think many, many people will appreciate. Yeah. So just to wrap things up, I want to say thank you to everyone. You know, this is very much driven by your feedback. A lot of the improvements you see here come directly from your feedback. And we look closely at your feedback in the forums, in support tickets. It's something we really take seriously. One of my favorite comments, not going to lie, this update made me gasp over and over so much I'm going to need an inhaler. So lots of great comments in the forums. If you're not there, check out the forum posts every 3 weeks with new updates. We pay close attention to them, both the forums and support tickets. And I just want to say thank you, everyone. This is a community that we really appreciate. The feedback, as I mentioned, we really appreciate. It was an amazing year for Onshape, and we could not have done it without your help. So we really encourage you, keep the feedback coming. We're moving really quickly. 2025 is going to be an awesome year. We're really excited about it. Lots of great stuff coming, and your feedback is helping us to drive that. So thank you, everyone, and have a good day.
Thanks very much. See you next year.